Okay, so now we're going to come up with the last modules in chapter 5, and we start with 5.13, 5.13, and it's called starting a shunt motor. He tells us in this section that if there aren't certain things that we watch out for, we can cause damage to both the DC motor and the thing that's connected to the DC motor. And there are certain things that we have to prevent, and he's come up with a list of 5 of those. So let's look at those and talk about them briefly. So here's a little outline of some of the potential problems that we might encounter when starting a DC motor. So we have to, we have to consider this in the control circuit that we develop. It's just not a matter of applying full voltage to whatever this machine is that we're connected to. There's provisions that we have to make because of the way that the machine, works. And of course, the primary consideration there for this DC motor is this large surge of current that you get at startup. So he says, starting a shunt motor, risk of starting current being very high, we can cause the following things, the damage to occur. One thing that we could do, he shows us, is that we are open to the possibility of burning out the armature from this surge of current. We also can damage the commutator and brushes because of the arcing and sparking that would occur between between the brushes and the commutator. That sparking that we talked about earlier that can occur. We can overload the feeder, the thing that's supplying the power to the motor. We can overload it. It can draw too much current. We can cause damage that way. We can cause damage to the shaft of the motor. We can actually snap the shaft from the mechanical shock of this surge of current and the huge torque that's created. And then there's also the possibility of damaging the device that we're trying to drive with the DC motor. There's a term that he gives us called hammer blow. And, hammer blow, it's just a term that means like a striking, like a hammer, and for something that's unbalanced in something, we could get that hammer blow, which can cause damage to it. So what we have to do when we're working with a DC motor is that we have to figure out a way to limit the current. And usually what we want to do is we want to limit the current to approximately 1.5 to 2 times the FLA, or the full load current. So we want to design this thing so that we can limit that current to this amount when it's at startup. Without that, those other things could possibly occur. One solution is to connect a rheostat, which is a variable resistor, in series with the armature, and then the resistance is gradually reduced as the motor starts to accelerate. And eventually, once you get up to full speed, you take it completely out of the equation. And then he goes on to say that there are electronic means, and we call these drives primarily. And this is a whole different world that we will explore in the second machines course. But it's an electronics means to do some of the things that we're going to talk about coming up in this section. So I'll end that there, and then the next thing we're going to look at is a way to limit the starting current.